Hey guys, well here we are again in Fusion 360, and in last week's video we worked on the base plate, and in this week's video we're going to work on the Vise Back Stop. Now we're going to have a push-pull toggle set up here, so we need this the back of the vise to be pretty stout. What we have here is a piece of 2" by 2.5" by 4 3/4" piece of mic 6. This is going to be a fairly short video. There's not really much machining we need to do on this vise stop. We've got to bore, drill, and thread mill these 3 holes. These are for some M10. And then we're going to put a M6 by 1 hole on each side, and that's just going to be for a stop, so when we slide our molds in it'll rest up against the stop and we can line everything up. The first setup is just to drill and thread mill these 3 mounting holes. We're going to set our 0 to the center of our stock here. We've got a center drill operation. I'm just using a 1/8" drill bit here and going down about 3/16 just to get started. Then we're going to come back with our second operation with a 5/16" drill bit. We're running 3,500 RPMs, plunging at 5 inches per minute. Our third operation is a boring operation. I'm going to bore the minor diameter with a 3/16" end mill to get my minor diameter. I don't do a lot of M10 threads, so I don't have a drill bit for the M10. So we're going to use the 3/16" end mill to get our minor diameter. And then last, we're going to come back with our M10 thread mill and do our thread mill operation. Now this M10 thread mill is a new thread mill. I also had to purchase this just for this project. Like I said, I don't really do a lot of M10. So we can take a look at how to set this tool up. Okay, so for this particular thread mill, it's M10 by 1.5. The cutter, now most of this information is found on the package that the cutter comes in. So it's a shaft diameter of 10 millimeters. The actual diameter of the cutter itself here is from the point to point is 8 millimeters. The length below the tool holder is 30 millimeters. Of course, this is user defined depending on how far you have a stick out. The shoulder length is 18 millimeters. I measured just to see what that is. These are usually tapered a little bit. So you can kind of fudge that just slightly to get a little bit more depth. Our flute length, you can just measure how long the flutes are. This one happens to be 4.5 millimeters. The thread pitch is 1.5. You don't have to do any conversion here. It's exactly what it is, 1.5. And then how many rows of teeth you have. This particular thread mill has 3 rows, and they are 60-degree thread profile. That's pretty much all there is to it in setting these up. The cutting data, I like running mine at 5,000 RPM. The feed rate, this is what the default is set up. This is what Fusion 360 spit out. 200 millimeters per minute. That's pretty much it for setting up the tool. Now, one thing I do want to point out, passes. the thread pitch, if you type in, we know it's 1.5 millimeters, and if you type that in here and then go out and come back in, if you're running your setup units in inches, it will convert this for you. So it's actually 0.05905551 is the thread pitch, or 1.5 millimeter. The pitch diameter offset is your major diameter minus your minor diameter. So the major diameter for an M10 is, of course, 10 millimeters. And I'm not sure what the minor diameter is. You can look it up on a thread chart. But you can adjust this slightly. If you want a little bit tighter threads, you can just decrease this number. Or if you need to be, the threads need to be just a little bit bigger, you can increase the pitch offset just a little bit. And that will just not take quite as much or take a little bit more. This is real good to kind of tighten up threads or loosen them up if you've got your threads are too tight, something's not quite right. So that's pretty much all the operations for this. Let's run the simulation here. The machining time on this is 12 minutes, it says. So we're going to use our 1/8 inch drill bit just to get our center drill. Come back with a 5/16 inch drill bit and get our full depth. Then we're going to finish this hole to get it to correct minor diameter with a 3/16 inch end mill, and we're just using a boring operation here. And then last, we're going to come back with our M10 by 1.5 thread mill. So that's pretty much it for that setup. And then for our side setup, we're just going to stand it up, and I'm just putting a hole in the center here. So we're using a 5 millimeter drill bit, and we're going to come back with our M6 by 1 thread mill and thread this hole. And then I'll just flip it over and do the opposite side. That way I can put the stop on the left or the right. But that's all there is to it for our Vise Back Stop. So now let's go out to the Precision Matthews and we'll machine this out. Okay, so I'm out in the shop today and I'm getting started on part of our clamping system that's connected to the base. This will go down in the pocket, and this will be the backstop for the clamping mechanism. This is also mic 6. This is 2 inches thick by 2.5 inches wide, and I'm just cleaning up all these edges, surfacing 4 sides here as well as the top and the bottom. This is actually 2.003, so it's a little bit thicker, 3/1000ths thicker than what it should be. So I'm just going to surface this, and so it'll fit down in the pocket just right. Alright, so next we have our, this is an M10 thread mill. Alright guys, next operation is we're just going to put a side hole. Originally I just drew it up for one side, but I think I'm just going to flip it and do a side hole on both sides. And this will just be for a stop so that we can get our mold in the same place every time. This is just a M6. Alright, I like to do just a little extra second pass on there just to clean the threads up. Alright guys, well there's the Vise Stop. It turned out really well. I was really, it's not a very difficult project to do. I only had to bore and drill and tap 3 holes, but I wanted to show you here on the base how I have these recessed into the base plate, and that's all due to that last little operation on the base plate that just kind of set the depth of this. It was just that final contour and pass that went down and I got that the way I wanted it, which was just below the surface there. The Vise Stop turned out well. The side holes turned out. This is just the M6, and I went ahead and did it on both sides, even though I drew it up only on one side, because I never know where I'm going to put the stop. In the next video, we're going to work on the spacer here for the push-pull toggle. That's to get it, raise it up just a little bit to get it right in the center, so that when we all our clamping force will be directed at the center. So stay tuned for that video. Guys, if you're new to my channel and you're just tuning in, click on that subscribe button in the bottom right hand corner. Also click on that notification bell. That way when I post a new video like this one, they'll send you a link, and if it's something you're interested in, you can stop by and check it out. As always, please feel free to ask questions, make suggestions, or leave comments. I'm new to the injection molding machine, so if you have any suggestions or thoughts on that, please feel free to comment. I'm always open to ideas. Thanks for watching, guys. Please subscribe. Thumbs up if you like the video, and most importantly, be safe.